Hey, we're going to get graphing here. We're going to graph quadratic functions. In this case, I'm going to show you the vertex form, how to graph a quadratic function in vertex form. We notice there are three forms to a quadratic function: the standard form, the vertex form, and the intercept form. So we are only dealing with vertex form here. So in the vertex form, you have y is equal to a, and then inside the parentheses you have x minus h squared plus k. Important part here is you have to remember that this is a minus sign. That's a minus sign, and this is a plus. You do have to memorize that part of it because that minus there is the tricky part. Why is h and k important? Because it gives you the vertex of the quadratic function. It tells you either the maximum or the minimum point depending on which way the graph opens up. So, and you notice here h is positive, but that's because there's a minus sign right there. We're going to talk about a situation. Actually, this situation right here deals with that because there's a plus sign right there. You see the plus sign there? We need to discuss that. So, how do we graph this? Well, what you should be thinking is that this is y equals -3, and the vertex form says it's supposed to be x minus a number. That's what the vertex form tells you. Look up here. X minus a number. Well, what is that number in this case? Well, how do we get a positive 2 here? We're going to have a -2. X minus -2 makes x plus 2. Okay, so there you go. First off, now let's identify the vertex. The vertex is h, which happens to be -2, and k, which happens to be a positive 4. And if we look at that, -2, positive 4, 1, 2, 1, 2, 3, 4. There you go. There's the vertex. Now, is this graph going to open up or is it going to open down? A will tell you that -3 right there. If it is a positive, it opens up. If it's negative, it's going to open down. So we know that this graph is going to look like this, roughly when we're finished. So you should know that. All right, so now make an XY chart here. And we're going to pick 5 points with the vertex of -2, 4 being the middle point. And why do we say that's the middle point? Is because this right here, this line is what we're going to call the axis of symmetry. The axis of symmetry, the equation for it is x equals -2. And remember, a quadratic is mirrored about this axis of symmetry. So let's go ahead and do the rest of our calculations and figure out what values we can have. If this is -2, let's go -3 and -4. And since we went down 1, I want to go up 1 to -1. And since we went down 2, I want to go up 2 to 0. And it's important to keep those equally spaced apart because it's going to save us some calculations in one moment. I want to deal with 0 and -1 because I think they're easier numbers to work with. So let's plug 0 in to this equation right here. So we're going to have y is equal to -3, 0 plus 2 squared plus 4. Well, 0 plus 2 is 2, and square it, we should get 4. Then you get -12 plus 4. And -12 plus 4 should be -8. And so we plug 0 in for x. Y was equal to -8. See the y comes down? Now remember, since it is symmetric, since a quadratic function is symmetric, Since 0 is 2 spaces away from the vertex, this number that is also 2 spaces away from the vertex will get a negative 8 with it. And now let's do the calculations for negative 1. So y is equal to negative 3, negative 1 plus 2 squared, and plus 4. Negative 1 plus 2 should give us 1. Square it. That gives us 1. And negative 3 times 1 is negative 3 plus 4. And that should be positive 1. Now tell me that since that one's 1, since when x equals negative 1, y is 1. 1 space away, y is 1. 1 space away, y is 1. So now that we're done with our calculations, let's go ahead and plot our points. 0, negative 8. 0, negative 8. And I know that this is 2 spaces away from the axis of symmetry, so that one's also 2 spaces away. And I believe that's the negative 4, negative 8 one. And we're looking at negative 1, positive 1, which is right here, and then negative 3, positive 1 right there. Draw your parabola. Make sure that when you draw it, it's a curve at the top of that and not a V. And there you go. You have graphed that quadratic function in vertex form. Typically, I don't put the axis symmetry on there. If you want to, that helps you out. Helps you look at the picture and see if it is symmetric. See if it's even on both parts. Does the distance from here match the distance to here? If I draw my lines perfectly, they would have. But they should. They should be close. Let's go through another example here. If you want to try this one on your own, you go ahead and do that. And then you can hit play and watch me work this one out. Once again, this is going to be x minus negative 3 squared. And that's what we have. And the reason why I'm doing that is so that way you can see that 8 in the vertex k, h is negative 3. K is negative 1. And look at A in front. A should be the invisible one that is positive. So we know that this graph is going to open up. It's going to open up. So if this is the vertex, negative 3, negative 1, I could go by 1, negative 4, and that would be negative 2. I could go by 2s, I could go by 3s, whichever is best for your situation, as long as that this distance and this distance from the vertex are the same, so that way you can use the what you know about the quadratic formula, or the quadratic function being symmetric. You can have the same number for the y, as long as they are the same distance from the vertex. Okay, so now let's plug in our numbers. Let's plug in negative 2 into the original equation. So y is equal to negative 2 plus 3 squared minus 1. Negative 2 plus 3 is 1. Square it, you get 1. And 1 minus 1 is 0. So when x is negative 2, y is 0. When x is negative 4, y is also 0. Negative 5 is 2 spaces away from the vertex, and negative 1 is 2 spaces away from the vertex. So now let's find the y values. Y is equal to -1 plus 3. We're going to square that and then subtract 1 from it. -1 plus 3 should be 2, and 2 squared is 4. And so therefore, y is going to be equal to 3. So when x is -1, y equals 3. When x is -5, y is equal to 3. And from this point, you just go ahead and plot the point. -2, 0. -4, 0. -1, +3, and -5, +3. And try to make sure that your arrows are pointing outwards and not directly straight up. And so there's the graph of that quadratic function. Okay, I have one last example here. One last example just to kind of give you a reminder of some things. Remember, if we're supposed to have y is equal to x minus h inside parentheses squared, and then we're going to add k to it. Well, what's k out here? K is going to be 0. There's nothing out there, so it's 0. And what is h? Well, is it -2 or is it +2? Remember, the formula is supposed to have a negative sign with it, or a subtraction, and this one does have that, so then h is going to be a +2. So in our table of values, we're going to put the vertex in the center, and let's do some calculations here. Y is equal to x minus 2. Well, let's let x be 0. 0 minus 2 squared. Well, we know this is -2, and when you square -2, you get 4. 0 is 2 spaces away from the vertex, so is +4. Now let's look at when x is 1. Y is equal to 1 minus 2. We're going to square it. 1 minus 2 is -1, so -1 squared should be a +1. Plot your points. 2, 0, 1, 1, and 0, 4. Symmetric. And there we have it. And there's the graph of the function from vertex form. That's all we have for this video.